Everything you think you know about Venus is wrong. For decades, we've dismissed our nearest planetary neighbor as simply a toxic, hellish world, but the truth is far more fascinating and strange. Venus isn't just Earth's evil twin, it's a dynamic world that might have once been habitable, could still harbor life, and hold secrets that completely change our understanding of planetary evolution. Let's explore what makes Venus perhaps the most misunderstood planet in our solar system. This is one of the first detailed radar maps of Venus, created by NASA's Magellan spacecraft in the early 1990s. And these are some of the only surface images we have, taken by Soviet Venera landers that survived just hours in the planet's crushing environment. The problem with these limited observations is that they've led to an oversimplified view of Venus as just a failed, dead world, when the reality is far more complex. The size of Venus is remarkably similar to Earth, it's about 95% of Earth's diameter and 82% of its mass. We often call Venus Earth's twin, and for good reason. If you placed both planets side by side, they would look almost identical in size. But that's where the similarities seem to end, at least according to conventional wisdom. For decades, the standard theory about Venus was straightforward. It formed like Earth but ended up too close to the Sun. This proximity triggered a runaway greenhouse effect, boiling away any oceans, creating a toxic atmosphere, and transforming the planet into the hellscape we see today. It's a neat, simple explanation that made its way into textbooks worldwide. But as with many things in science, the reality has turned out to be much more complex. Our first real breakthrough in understanding Venus came in the 2010s, and it involved one of the most unexpected discoveries in planetary science. In 2020, an international team of astronomers detected phosphine gas in Venus's atmosphere, a chemical that, on Earth, is primarily produced by living organisms. This wasn't supposed to be possible on Venus. The discovery was controversial, with some scientists questioning the data. But it forced us to reconsider everything we thought we knew about our sister planet. If there was even a small possibility of life existing in the clouds of Venus, then clearly we had been missing something fundamental about this world. This revelation coincided with new climate models suggesting something even more shocking: Venus might have been habitable for billions of years. Not just briefly, but for most of its history, possibly until as recently as 700 million years ago. That's well into the time when complex life was flourishing on Earth. So what happened? How did a potentially Earth-like world transform into what we see today? The answer appears to be catastrophic volcanic activity on a scale that's difficult to comprehend. Venus experienced what scientists call a global resurfacing event, a period of intense volcanic eruptions that essentially repaved the entire planet. Imagine every volcano on Earth erupting simultaneously, and continuing for millions of years. The evidence is written across Venus's surface, where 80% of the terrain consists of volcanic plains, with over 1,600 major volcanoes and countless smaller ones. This volcanic cataclysm released enormous amounts of carbon dioxide, creating the runaway greenhouse effect that transformed Venus. But here's the twist: this may not have been Venus's first global resurfacing. New research suggests Venus might undergo these catastrophic cycles every few hundred million years, alternating between periods of relative stability and volcanic apocalypse. This cyclical nature could explain one of Venus's most puzzling features: its surface appears remarkably young by geological standards, with most features dating to roughly the same age, about 500 to 700 million years. It's as if the planet's entire history before that point was erased, because it literally was, buried under fresh lava flows. But let's talk about what Venus is actually like today, beneath those iconic swirling clouds. First, those clouds themselves are nothing like Earth's. They're composed primarily of sulfuric acid droplets and extend from about 50 to 70 kilometers above the surface. They completely enshroud the planet, reflecting about 75% of incoming sunlight back into space. Despite being closer to the Sun than Earth, Venus's cloud-covered surface actually receives less solar energy than our planet. But that doesn't make it cool, quite the opposite. The thick carbon dioxide atmosphere traps heat so efficiently that the surface temperature reaches about 462 degrees Celsius 864 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. The atmospheric pressure at Venus's surface is equally extreme, about 92 times greater than Earth's sea level pressure. It's equivalent to the pressure you'd experience about 900 meters, 3,000 feet, deep in Earth's oceans. This crushing atmosphere isn't just carbon dioxide, it contains layers of complex chemistry, including the mysterious, unknown absorber that creates dark streaks in the clouds and absorbs ultraviolet light. These clouds create perhaps the most alien weather system in our solar system. The entire cloud layer circles the planet in just 4 Earth days, what scientists call superrotation, since it moves 60 times faster than the planet itself rotates. Venus has the slowest rotation of any planet, taking 243 Earth days to complete a single day-night cycle. But the most surprising thing about Venus's atmosphere isn't its composition or pressure, it's where habitability might be possible. Between approximately 48 to 60 kilometers above the surface exists a zone where temperature and pressure are remarkably Earth-like. In this narrow band, you could theoretically walk outside a protective vessel wearing just an oxygen mask and acid protection, though you'd still need something to stand on, of course. This temperate zone is precisely where scientists detected phosphine and where some theorize microbial life could potentially exist, floating in the clouds, much like microorganisms inhabit Earth's upper atmosphere. These hypothetical Venusian microbes would need to evolve acid resistance and a way to stay aloft, but neither adaptation is beyond what we've seen life accomplish on Earth. As we descend below the clouds toward Venus's surface, the environment becomes increasingly hostile. The thick atmosphere creates a powerful greenhouse effect, trapping heat and creating those infernal surface conditions. But it also generates another strange phenomenon, supercritical carbon dioxide. Near the surface, the temperature and pressure are so extreme that carbon dioxide enters a supercritical state, neither truly gas nor liquid, but with properties of both. This exotic form of matter can dissolve metals from surface rocks, potentially creating a thin, metal frost, on the highest mountain peaks where the temperature is slightly cooler. The surface itself is unlike anything in our solar system. Venus has no plate tectonics as we understand them on Earth. Instead, the planet's crust appears to be a single, rigid shell. But this doesn't mean it's geologically dead. Recent studies suggest Venus still experiences volcanic activity, with evidence of eruptions potentially occurring as recently as a few years ago. The planet's surface features are equally bizarre. Venus has vast volcanic plains, highland regions called tesserae, with complex ridges and valleys, and unique formations like pancake domes, flat, circular volcanic features unlike anything on Earth. Perhaps most mysterious are the coronae, enormous ring-shaped structures formed by upwelling magma that can span hundreds of kilometers. One of the most surprising discoveries about Venus in recent years involves its rotation. For decades, we believed Venus rotated at a nearly constant rate. However, radar observations revealed something astonishing: Venus's rotation rate appears to vary by about 20 minutes. The entire planet seems to speed up and slow down. The leading theory suggests this variation is caused by Venus's thick atmosphere. As it circulates around the planet, the atmosphere exchanges angular momentum with the solid planet, slightly altering its rotation rate. Essentially, the atmosphere is so massive it can push against the planet itself and change how fast it spins. Even more recently, scientists discovered that Venus has a day-side bulge, a feature where the planet's crust rises up slightly on the side facing the sun. This shouldn't be possible on a slowly rotating planet with a thick crust. It suggests that Venus's interior might be more fluid than we thought, responding to tidal forces from the sun much like Earth's oceans respond to the moon. This brings us to perhaps the greatest mystery of Venus, its interior structure. Without seismic data, no lander has ever carried a seismometer to Venus. We've had to make educated guesses based on the planet's mass, density, and magnetic field. The traditional view held that Venus has a structure similar to Earth, a metallic core, rocky mantle, and thin crust. But new models suggest Venus's interior might be fundamentally different. Its core may be partially or entirely solid, unlike Earth's liquid outer core. This would explain why Venus lacks a significant magnetic field. Without a flowing liquid metal core, there's no dynamo effect to generate one. The absence of a magnetic field has profound implications. Without this protective shield, Venus's atmosphere is directly exposed to the solar wind, the stream of charged particles flowing from the sun. This constant bombardment strips away lighter elements from the upper atmosphere, particularly hydrogen, which explains why Venus has so little water compared to Earth. But here's where the story takes another unexpected turn: Venus might not have always lacked a magnetic field. Recent research suggests that the planet's slow rotation isn't its natural state. Venus may have once rotated much faster and possessed a magnetic field similar to Earth's. What could have caused such a dramatic change? The leading theory involves a massive impact or series of impacts, similar to the collision that formed Earth's moon. But instead of creating a satellite, these impacts may have essentially reversed Venus's rotation, leaving it spinning slowly in the opposite direction from most planets. This impact hypothesis might also explain another Venus mystery: why the planet lacks a moon. If Venus once had satellites, they would have been destabilized by the same events that altered its rotation, eventually crashing back into the planet or being ejected from its orbit. Our understanding of Venus is about to undergo a revolution. After decades of neglect, 3 major missions are now headed to our sister planet, NASA's Veritas and DAVINCI Plus and the European Space Agency's Envision. These spacecraft will map Venus's surface with unprecedented detail, analyze its atmosphere, and potentially determine whether the planet is still volcanically active. The DAVINCI Plus mission will even send a probe plunging through Venus's atmosphere, capturing the first direct measurements since the Soviet Venera missions of the 1970s and 80s. If there is microbial life floating in those clouds, we might be on the verge of discovering the first extraterrestrial organisms. Venus remains one of the most fascinating yet misunderstood worlds in our solar system. Every answer we find only leads to more questions. It's not just Earth's evil twin, it's a dynamic world that challenges our understanding of how planets evolve and where life might exist. The next time you see that brilliant point of light in the morning or evening sky, remember, Venus isn't what you think it is. It's far stranger and more wonderful than we ever imagined.